today we are going to take a look at solving logarithmic equations. We're going to look at two types. The first type is if I have a log set equal to a log. So copy these steps down in your notes. Okay, the first step is to condense each log. That's what we were doing in our last lesson. Okay, we were condensing each log using those three properties of logs. So we want to get it to where we just have one log equal to one log. We may have multiple logs on each side of the equation, but we want to condense that. Once we have one log equal to one log, we'll use the one-to-one property, which says if I do have one log equal to one log, where they have the same base, I can just take whatever's on the inside and set that equal. Then the final step is to solve this equation and check our solutions. We have to check our solutions because we cannot take the log of a negative number. So by check, we just mean plug the value that we get back in and make sure that none of the logs are negative. None of the inside values are negative. If it is negative, if we do get a negative value, then we will have an extraneous answer. Okay? So I'll give you a second here to finish copying these steps down, and then we'll take a look at an example.
I might have done that yesterday. The last practice and graded assignment that we did. I hope, because it's not in there.
Alright, so first example here, we got log base 5 of 5x plus 9 equals log base 5 of 6x. My first step is to condense each side of the equation to a single log. I already have that. Right? I've got one log equal to one log. Once I have that, I can just take whatever's on the inside of the two logs and set that equal. So I can just say 5x plus 9 equals 6x. Now we have a pretty simple equation to solve. So, subtract 5x from both sides. We get x equals 9. Now, the final step is to check our answers. So we need to take this value of 9 and plug it back into the original equation wherever we see an x. So I have x's on both sides here. So I would need to say log base 5 of 5 times 9 plus 9, and log base 5 of 6 times 9. So what's 5 times 9 plus 9? 54. Yep, so log base 5 of 54. And what we're really checking to make sure is that we get a positive value here. We did it, so we're good. Over here, I would get the same thing, right? I would get log base 5 of 54. So positive value inside the log, positive value inside the log. That means we're good, and 9 is a legitimate answer. Okay, so our process here, get one log equal to one log, then just set what's on the inside equal, solve, and then plug it back in to make sure we get positive values inside of every log. Questions? All right. Why don't you guys try? No, numbers 2 and 3. Okay, 2 and 3 are the same process. Okay, we already have 1 log equal to 1 log. So on both of these, we can just go ahead and set what's on the inside equal. Solve that equation, and then check our answer. So take a minute or two here and try numbers 2 and 3. On number 4, something a little different happens. So we'll do 4 together here. So you can check your answer for number 2 on the board. Okay, we keep going and try number 3 then. What do you mean? -7 for the answer. So, yes, you could do this. for number 2, we should get negative 7. And when I plug that into my original 2 logs, we should get 2 positive numbers, 29 and 29. So that means negative 7 is a legitimate solution. Okay. On number 3 then, okay, same setup. We already have 1 log equal to 1 log, so I can just set what's on the inside equal. So I can say 6 minus 3w equals negative 2w. To solve, all I would need to do is add 3w over here. So then we get 6 equals w. But then let's plug it back in. So if I plug 6 in over here, I've got log base 9 of 6 minus 3 times 6. And then over here I would have log of negative 2 times 6. Well, over here, 3 times 6 is 18, so 6 minus 18 would get me negative 12. Same thing over here, I would get log base 9 of negative 12. We cannot take the log of a negative number. So if I get a negative inside of the log, when I plug my answer back in, that means that answer is extraneous. So 6 is not an answer. Since 6 was the only possible answer that we got, and it ended up being extraneous, that means there are no solutions to this problem. Okay, are we okay with this extraneous idea? Okay, so it is important to plug our answer back in. Right? If when we plug our answer back in, we get a negative inside of the log, that means it is not an actual answer. It's extraneous. Questions on that idea?
Why did you put negative 12 in the second one instead of 6?
Well, I plugged in 6 for w. So we have negative 2 times 6
Oh,
is negative 12. Any other questions on that one? All right, then on 4, we've got a little bit different situation. And on this one, I have 2 logs on the left side of my equation. The first step in my process for solving is to get 1 log equal to 1 log. If I'm adding 2 logs over here, how can I combine those into a single log? So this is the properties of logs that we talked about in the last lesson. Right, if I'm adding 2 logs together, I can combine them into a single log by multiplying what's on the inside. So I can say this would be the same as log of 4 times y plus 5. Okay, whenever we're adding 2 logs, we can just multiply what's on the inside. And I'm not doing anything to this side. So over here, I would need to distribute this 4 through to both the y and the 5. So we have log of 4y plus 20 equals log of 72. Now I do have 1 log equal to 1 log. Now we can just take what's on the inside and set that equal. So I can say 4y plus 20 equals 72. Then subtract 20. 4y equals 52. Divide by 4. 13. And we get 13. So we do need to check to make sure this is a legitimate solution. The only place there's a y in my original equation is this first log, so that's the only one I really need to plug it in to make sure that we get a positive value. So I would have log of 13 plus 5. 13 plus 5 is definitely a positive value, right? So that works. So 13 is a legitimate solution. You okay with that one? All right, let's do number 5 together here as well. So on this one, we kind of have 1 log equal to 1 log, but I've got a number out in front. I've got a coefficient on this first one. Right. Okay. Whenever we have a coefficient, we can move that up as an exponent. So to use the one-to-one property, saying 1 log equals 1 log, we can't have coefficients either. We need to use our power property and move this up as an exponent. So I can say this is the same as log base 7 of 4 to the 3rd power. And then I didn't do anything to the right side, so that's still log base 7 of 4a minus 8. What's 4 to the 3rd power? Kind of big. 64. So this would just be log base 7 of 64 equals log base 7 of 4a minus 8. Now I can use my one-to-one property and say what's on the inside here will equal what's on the inside here. So 64 equals 4a minus 8. Two-step equation. So add 8 to both sides. We get 72 equals 4a. Divide both sides by 4. And we get 18. Yes. Just need to blow my horn. Yes, it's kind of. So plug 18 back in. The only place that I have a variable in my original problem is in the second log, okay, on the right side of the equation. So if I plug 18 in here, we would have log base 7 of 4 times 18 minus 8. 4 times 18 minus 8 is definitely a positive value, so that works. So 18 is a legitimate solution. Questions? Dinah put those in there for an experiment, I guess. All right, we're going to take a few minutes here, and you guys try 6, 7, and 8.
Oh.
Okay, 6, 7, and 8.
So that.
What's up? Sir? So since we're subtracting the 2 logs, the property we talked about before we're subtracting is we can put 5 that's on the other side. So we can just divide it.
Bro.
Up through number 8. So 6, 7, and 8. Another minute or two here. Try to finish up through number 8. We've got number 6 on the board here. You can check your work for number 6. So did we get 2 for number 6 here? Okay, the big property that we need to use is whenever I'm subtracting 2 logs, I can combine them into a single log by dividing what's on the inside. Okay, that was the key to starting this one. And then when we solve, we should get 2 versus, yeah, 7 would be less. And then when I plug this back in, I would only need to plug it into this log since that's the only n, and I would get a positive value, so 2 is a legitimate solution. Okay. Then on number 7, the 1/2. So whenever we have a coefficient, no matter what that coefficient is, even if it's a fraction or a decimal or a negative number, we can bring that in as a power. Right, so I can say that this is log base 6 of 25 to the 1/2 power. So I didn't do anything to this side, so that'll stay. What's 25 to the 1/2 power? 5. The 1/2 power is the same thing as square root. Okay? So it's not multiplied by 1/2, it's 1/2 power. So this would be the same as log base 6 of 5 equals log base 6 of 23 minus 4w. Now I've got 1 log equal to 1 log. I can just take what's on the inside, set that equal. So 5 equals 23 minus 4w. Then subtract 23 from both sides. We would get negative 18 equals negative 4w. Divide both sides by negative 4, and we would get positive 4.5, or 9/2 if you want to make it a fraction. Then we would need to plug it back in, so I would only need to plug it into the right side since that's my only w. So log base 6 of 23 minus 4 times 4.5. This is a positive value if we plug that into the calculator. So that works. So 4.5 is a legitimate solution. You okay with that one? Then number 8. Okay, on the right side of the equation here, we actually have to use 2 properties to condense this side into a single log. Okay, first, I have a coefficient on just this log, so I would need to bring that coefficient up as an exponent. So I'm not doing anything to this side. So log base 3 of 2p minus 5. Now if I bring this up, I would have 6 to the 2nd power. 6 to the 2nd power is just 36, so I'll go ahead and write this as 36 minus log base 3 of 4. Well, now if I'm subtracting 2 logs, I can combine those into a single log using division. Right? So again, I'm not changing this side, but now I can divide 36 by 4 and say this is just the same as log base 3 of 9. You just left it as 6 squared. No, that's okay. Yeah, I mean, did you get log base 3 of 9? Yeah, that's fine. Yeah. So now I've got 1 log equal to 1 log. I can just say 2p minus 5 equals 9. 2-step equation to solve for p. Add 5 to both sides. And divide by 2. Get p equals 7. Then we need to plug that back in. The only p in my original equation is on the left side here. So log base 3 of 2 times 7 minus 5. So that'd be 14 minus 5 is 9. That is a positive value. So 7 is a legitimate solution. Any questions on this first type of equation? Alright, we're going to skip 9 and 10. So go ahead and flip over to the back. We're going to take a look at the second type of logarithmic equation. Okay, in this one, instead of a log equal to a log, we've got a log equal to a number. So copy these steps down in your notes. Okay, step 1 is to condense and isolate the log. So condense means there may be multiple logs on the left side of the equation. We would need to condense them into a single log. And then isolate, well, we could be multiplying the log by something or adding or subtracting something to the log. We would want to move all of that to the other side. Okay, that's what the isolate part is. Then, once we have just a single log equal to a number, I want to rewrite that in exponential form. Okay, this is what we talked about a couple of lessons ago. This was that lazy 7 thing. Okay, rewriting the log in exponential form. Then solve that equation and check for extraneous solutions. So go through a couple of examples of this here. Give me a minute to finish copying these steps down. Sure. Alright, so on this first example, I've got log base 2 of x minus 4 equals 6. So my first step is to condense and isolate the log. Well, I already have one log, and it is isolated. I'm not multiplying by anything. I'm not adding or subtracting anything outside of the log. So I can go ahead and go to step 2. Step 2 is rewrite in exponential form, which means the lazy 7 thing. So the base of the log will become the base of the exponential. Then we would say 2 to the 6th power equals x minus 4. Now we can solve this equation. What's 2 to the 6th power? 64.
I'm retarded.
2 to the 6th power is 64. Then all I would need to do to solve for x is add 4 of them. So we get that x is 68. We need to check our answer then. So if I plug 68 into this log base 2 of 68 minus 4, that's definitely a positive value. Right? So we're good. So 68 is my answer. We okay with that one?
Yeah.
Sure. All right, let's take a look at number 12 together then. On this one, the log is not isolated. Okay? I am subtracting 7 outside of the log. So let's add the 7 to the other side. That will isolate the log. Okay, so we would just get log base 3 of 4x plus 8 equals 4. Now the log is by itself. Okay, the log is isolated now. Now I can rewrite this as an exponential. So what would that look like? Right, 3 to the 4th power equals 4x plus 8. What's 3 to the 4th power? 81. So 81 equals 4x plus 8. Subtract the 8 over. You get 73 equals 4x. Divide by 4, and this doesn't reduce as a fraction. So I could just leave this as 73 over 4. Or if we wanted a decimal, I think that works out to 18.25. Then we would need to check our answer. So if I plug 73 over 4 into this log base 3 of 4 times 73 over 4 plus 8. I don't have to figure out exactly what that will be. All I really care about is that a positive value? That will certainly be a positive value. Right? 4 times a positive value plus a positive value. So 73 over 4, or 18.25, is my answer. Feel okay with that one? I mean,
I know we do that.
but, like on the front, we came up with one where it didn't work, right? We did all the correct work. We got W equals 6, and then when we plugged it back in, it didn't work. It ended up being extraneous. So, I mean, if you don't check, you may get wrong answers because you'll miss answers that are extraneous. So, I mean, if you miss answers that are extraneous, that is wrong. Yeah, so for the next one, we've got 2 logs on the left side, right? I need to condense that into a single log. So that's what we looked at those properties on the front. So how, if I'm adding 2 logs, how would I condense this into a single log? Times, multiply, right? So I could say this is log of 2x times x minus 5 equals 2. So I would need to distribute this 2x. So we would say this is log of 2x squared minus 10x. Now I've got one log equal to a number. Now I can rewrite it as an exponential, or do the lazy 7 thing. Right. There isn't a base for any of these logs. If there isn't a base written, we know that means it is base 10. Right? That's the common log. So we need to know that to be able to rewrite this as an exponential. So now I would say 10 to the second power equals 2x squared minus 10x. What's 10 to the second power? 100. So we get 100 equals 2x squared minus 10x. How would I solve something like that? How would we solve a quadratic? Yeah, we want to x factor, and that's the goal. But what do I need to do first before I can x factor? Subtract the 100 over, right? I want to get everything on one side equal to 0. So if I subtract 100 over, I will have 0 equals 2x squared minus 10x minus 100. Okay, now we could x factor from here, but there is one thing we could do first that will make the x factoring a lot easier. Take out a 2, and to simplify. So if I take out a 2, I would end up with x squared minus 5x minus 50. Now that'll make the x factoring here a lot easier. So now I want 2 numbers that multiply to negative 50 that add to negative 5. 10 and 5. 10's negative, right? So now since my leading coefficient is 1, these are my factors. Right? So I can say this is 2 times x minus 10 times x plus 5. So how do I get my answers then? So we want to set each of these factors equal to 0. Right? So if I say x minus 10 equals 0, I would add the 10 over and get x equals positive 10. Similar idea here. If we say x plus 5 equals 0, I would subtract the 5 over and get x equals negative 5. So we got 2 answers here. We need to check both of them in my original equation. So when I do that, if I plug in 10, I'll have log of 2 times 10 is 20. Log of 10 minus 5 is 5. So that works, right? Both of those end up being positive. So 10 is a legitimate solution. If I plug in negative 5, 2 times negative 5 is negative 10. That's no good. So negative 5 is not an answer. That is an extraneous solution. So our only answer here is positive 10.